Hi, my name is Takuro. I'm a sound designer based in Berlin, Germany. In this video, I'll show you how to create an audio visualizer using the sequencer in Unreal Engine 5. There are several ways to build audio visualizers in Unreal Engine. And you might have experienced that the video looks fine in the editor, but when it's rendered, the timing between the audio and the visual element is not in sync anymore. This happens when using the audio envelope follower or the audio submix envelope follower. In this video, I'll show you why that happens and how to fix it, so you can create a clean, synced audio visualizer. Let's have a look at this example. I rendered this video using the audio envelope follower from the sequencer. So as you can see in the video, the visuals are completely out of sync with the audio. It almost looks like the cube is scaling randomly, and that's because the audio envelope follower gets data from the audio thread, which isn't synced with the rendering thread. To fix this, we need to handle both the audio analysis and the visual updates on the same thread, so everything stays in sync during rendering. Okay, let's start. First, we need to enable Audio Synesthesia plugin, which is in the plugin settings, audio, you need to turn on this plugin or make sure that it's on. Okay, let's create Audio Synesthesia asset. Under audio analysis, synesthesia NRT, and loudness NRT, LNRT, music, and in this asset you can set audio file. I'm going to use this music file. And for the music visualizer, we need a blueprint actor. I've already created one. Okay, let's open it. And you only need one function. I created a function called getLoudness. Let's have a look at the variables first. First, LNRT. That's the asset I created earlier. Loudness NRT. And here I can set the one I made. I also have attack and release time variables, and they work like in an audio compressor. And here is a variable to store a previous output value. And this is going to be used to calculate attack and release time values. The reason why I calculate the values in this function is to make sure that the new value is dependent on the value from the previous frame. And overall, the function looks like this. Let's have a look at the input. Start offset seconds and frame time. Start offset seconds can be used when you want to play the audio file later than 0 seconds. It is very useful if you want the visualizer to start after an intro, for example. So here you convert the frame time structure to seconds and subtract offset time. And then the value goes into the function from LNRT. Get normalized loudness. And the output value of this function is normalized. So the value is between 0 and 1. And that goes into a local variable. It's actually not very necessary to create these local variables. But to make it easier to understand the code, I made these variables. And if you don't need attack and release time functionality, you can feed the output value of this function straight into the output node. So here's the calculation of attack and release time alpha. So you get a frame time structure and break it to get frame rate structure. And you take a numerator, and that's the FPS of the sequencer as integer. And here's the calculation of final output based on alpha and previous output value. And that goes into the return node. And here it selects either attack value or release value. And if the current loudness is bigger than the previous loudness output value, it takes the attack value. And if it's less than the previous output value, it takes release value. And here's how the function looks like. Okay, now let's implement the blueprint into the sequencer. And in the sequencer, we have a music file as a reference. And in the level, we have a cube. And we are going to change the scale of this one based on music. So let's place the blueprint into the level. And in the sequencer, add to sequence and select the blueprint. And click on the plus sign and event repeater. And this way, you trigger the event every frame in the sequencer. And then double click to create an event. I actually created one already, but let's do it again. First, let's get the function, get loudness, and then let's get the current time from the sequencer. Get current time. So this returns a current playhead position of the sequencer. And it goes to frame time. So now we want to change the scale of the cube. And to do that, first we need to create an input. Let's call it cube. And it's static mesh actor. And set actor scale 3D. Okay, let's just simply add the loudness value to scale of 1. Let's create an input for start offset seconds. You can simply drag to the event to create an input. There's one more thing. Let's check calling editor. So by doing this, you can see the changes while scrubbing through the sequencer. Let's check if it works. Okay, let's check attack and release times. I'm gonna set the attack time to 0.5 seconds. As you can see, now it's less jumpy. It moves a lot slower. And let's change the release time and to 1 second and 2 seconds and 5 seconds. It's really slow. Let's bring them back to the default values. 0.01. Now we are ready to render the video. Here's a rendered video. And let's play it. Not like in the other video I rendered earlier, everything is in sync. If you want the visualizer to react to different instruments, you can simply create audio stems and repeat the process. Thank you very much for watching. I hope this video was helpful. See you in the next video. Bye.